Students, in the chapter The General Principles and Process of Isolation of Elements, let us discuss another topic, and the topic is extraction of non-metals by oxidation. So our topic for discussion is extraction of non-metals by oxidation. So we all know that the extraction of metals is done by reduction, and the non-metals, they are present in combined state. So extraction or isolation of non-metals can be done by oxidation of their compounds. So how the extraction of non-metals can be done? It can be done by oxidation of their compounds. So a very common example of extraction based on oxidation is isolation of chlorine from brine. What is brine? NaCl, sodium chloride solution, is called brine. So isolation of chlorine from brine is, we know that brine is abundant in seawater, or chlorine is abundant in seawater as common salt. So in common salt, chlorine is abundant in seawater. So what is the reaction? Cl chloride ion plus water in liquid state, it get converted into hydroxide ion plus hydrogen gas plus Cl2 or chlorine gas. So we have to balance the reaction. Now the reaction is balanced now. Now oxidation cannot be carried out by ordinary chemical methods. So by ordinary chemical methods we cannot carry out the oxidation. So therefore the delta G naught. What is delta G naught? Change in Gibbs energy, standard Gibbs energy for the reaction. The reaction which is written above is equal to plus 422 kilojoule. This is the value for delta G naught for the above reaction. So what will be the minimum potential difference required for oxidation can be calculated. How can this be calculated? We can calculate it by like this. We know that delta G naught is equal to minus NF E naught of cell. This is the relationship between Gibbs energy and E naught of cell. E naught of cell means standard electrode potential. E naught is standard electrode potential. So how can we calculate? We have the value of delta G naught is equal to plus 422 kilojoules. So by putting the value of delta G naught 422, the value is in kilojoules, so let us convert it into joules. So we have to multiply 422 multiply 1000 is equal to minus. What is the value of N? N means number of electron gain or loss during the reaction. From this reaction we have seen that 2 electrons are gained and 2 electrons are lost. So number of electrons in this reaction means the value of N is 2. And what is the value of Faraday's constant? F is Faraday's constant. F is Faraday's constant, and the values of Faraday's constant is 96500, and we have to calculate E naught of cell. So from this equation, E naught of cell is equal to, the value will be equal to minus 2.18 volt, or approximately equal to minus 2.2 volt. So standard EMF for this cell will be equal to minus 2.2 volt. So due to over voltage, actual electrolysis requires an external EMF which is greater than 2.2 volt. So we have to require an external EMF which should be greater than 2.2 volts. So due to liberation of gases, we see in this reaction that there is liberation of hydrogen and chlorine gas. So due to this liberation of hydrogen and chlorine gas, extra voltage is to be required. Then the theoretical value of standard electrode potential. So we require extra voltage because here the standard electrode potential will be 2.2 volts. So we need an extra voltage for this. That standard electrode potential value which is required more than the theoretical value is called over voltage. When we require extra voltage, it is called over voltage, or it is also called bubble voltage. So what happens during electrolysis? During electrolysis, chlorine Cl2 is liberated at anode and H2 is liberated at cathode. So chlorine is liberated at anode and H2 is liberated at cathode, and NaOH, sodium hydroxide solution, NaOH is obtained in the salt solution. NaOH will be obtained in the salt solution, and therefore H2 and NaOH are the byproducts of electrolysis. if we have to explain the electrolysis of molten NaCl, then what are the products which are liberated at cathode and anode? So in NaCl, in case of NaCl, sodium metal is liberated at cathode and chlorine is liberated at anode. So this is the method for extraction of non-metals by oxidation. So extraction of metals by both oxidation and reduction. So extraction of metals by oxidation and reduction, we have already discussed extraction of gold and silver, which involves the process called leaching. Leaching method is used for extraction of silver and gold. In leaching, it involves leaching of metal present in the ore with cyanide ions. So leaching of ore of the metal is done with cyanide ions. This is oxidation reaction in leaching process. So in this Ag, silver is oxidized to Ag plus and gold Au is oxidized to Au plus. They then combine with cyanide ion to form respective soluble complexes. So what are the reactions? Ag, it reacts with cyanide ions and it will form a complex. What is the complex? Silver cyanide will be the complex and hydroxide ions. So this is the reaction. We have to balance the reaction. This is the complex which is formed by silver, and this complex is soluble complex. Same reaction is for gold also. Au plus cyanide plus water plus oxygen, it will form a complex. In case of silver, here it is gold, Cn whole twice plus hydroxide ions. Now you have to balance the reaction. So this is also soluble complex. In this, your Au is solid, cyanide is in aqueous state, this is liquid, this is gas, and this complex is aqueous in nature. Hydroxide, it is also aqueous. Same here, aqueous, liquid, and this is in gaseous state. This your complex is aqueous and this is also aqueous. So soluble complex is formed in this. So the next, how metals are recovered then? The metals are recovered from these complexes by reduction. Firstly we do the oxidation, now we have to do the reduction or displacement method using a more electropositive metal. So we have to recover the metal silver and gold. So their complex is formed as discussed earlier. We have to do the reduction or displacement method. We have to use a more electropositive metal. Means from silver and gold we have to use a metal which is more electropositive than silver and gold. So let us take electropositive metal like zinc, because zinc is more electropositive and zinc is more reactive as compared to silver and gold, and it can displace also the soluble complex which is formed earlier. So what is the soluble complex for silver? AgCN whole twice aqueous. This complex we have discussed earlier. When zinc is reacted with this soluble complex, what will happen? Zinc will displace silver from this soluble complex, and what will formed? Ag solid will be formed plus the complex ZnCN4 2 minus aqueous. So this reaction is called displacement or reduction reaction. Same reaction can be written for gold also. 2 AuCN whole twice minus aqueous plus zinc solid, and we get gold plus the complex is formed by zinc, and this reaction is called reduction reaction or displacement reaction. So zinc here act as reducing agent in both the displacement reactions. Zinc act as reducing agent. So we conclude that extraction of copper from low grade copper over gold and silver are also extracted from these ores by hydrometallurgy. So hydrometallurgy is the process by which the extraction of copper, silver, gold takes place. What is hydrometallurgy? The process of extraction of metals by dissolving the ore in suitable reagent, followed by displacement of metal by a more reactive or electropositive metal is called hydrometallurgy. hydrometallurgy. So what is hydrometallurgy? The process of extraction of metals, the extraction of metals like silver and gold by dissolving the ore in suitable reagent. Then we have to follow the displacement, which is called reduction of the metal, and then we have to do the reduction or metal by suitable electropositive metal like that of zinc we have used here. It is called hydrometallurgy. So we have discussed two topics here: extraction of non-metals by oxidation and extraction of metals by both oxidation and reduction. So thank you